The mountain exhales and the sky turns to fire. A glowing cloud of gas and stone tears down the slope in seconds, swallowing an entire city before its church bells stop ringing. Then silence. Based on modern volcanology, researchers estimate this glowing avalanche moved faster than a Formula One car, hot enough to melt glass in seconds. But if a mountain like this stirred again above a city today, the same forces could unfold in hours, not centuries, testing every warning system we have built since. To understand how we get there, we start with what this volcano on a small island in the Caribbean has already done. Martinique, in the eastern Caribbean, is a small green island wrapped in blue water, and at its northern tip stands Mont Pelée, a quiet, cloud-wrapped mountain watching over the old port city of Saint-Pierre. In April 1902, the mountain stirred. Ash drifted over rooftops, the air turned sour with sulfur, and small bursts of steam rattled the crater, early warnings before the real one. Picture the rock peeled away from the summit. Deep inside sits a chamber of thick, gas-choked magma, too stiff to flow, only to swell. A narrow throat, the conduit, carries it toward the surface, and a plug of hardened rock, the dome, seals the top like a cork in a shaken bottle. When the pressure beats the cork, the whole side can give way. Then the rock closes over it again, and the mountain looks calm. On the morning of 8th May 1902, the side of the crater gave way. A glowing cloud of gas and shattered rock poured down the slope and struck Saint-Pierre within minutes, hot enough to ignite stored rum casks and melt glass in the city's warehouses. Of the roughly 28,000 people living there, almost none survived. In the months that followed, a tower of solid lava rose from the broken dome, a spine of rock scientists still study today. The disaster even gave this kind of blast its own name, a Pelean eruption. But what exactly triggered that fatal breach, and whether it could happen again, are questions we're only beginning to answer. Today, the Observatoire Volcanologique et Sismologique de Martinique keeps a constant watch on Pelée, tracking tiny tremors and shifts in the ground that hint at magma on the move. Their work helps answer a question the 1902 disaster left open. What actually triggered that lateral blast? Researchers believe the culprit was a hidden breach in the crater wall, a weak seam that let the pressurized cloud punch sideways instead of straight up, sending it directly toward the city below, rather than spreading evenly around the cone. Modeling suggests the glowing current itself moved between 100 and 200 meters every second, well over 300 kilometers an hour, arriving almost as fast as the eye could follow it. Internal temperatures likely ranged from 200 to 700 degrees Celsius, hot enough to char wood and melt glass, but not always hot enough to burn everything to ash, which is why some walls were found scorched rather than erased. If a similar breach opened today, aimed at a modern coastal town, the same physics would apply, only faster, since so much more now stands in its path. But what if it goes further? Picture this same mountain stirring again, only now above a coastal town, wired with sensors, cameras, and open evacuation roads. Hour 0. Seismographs catch the first faint tremors before sunrise. Fresh magma is pushing upward toward a dome already stretched thin. Underground, the danger is simple. Gas-charged magma pressing up a sealed conduit, and the dome plug holding it down like a cork. By day 1, the summit visibly bulges, swelling like a blister about to burst. Sirens sound along the coast, and evacuation convoys stream out of the mountain's shadow, buying hours nobody in Saint-Pierre ever had. Within hours, volcanologists flagged the bulge as critical, something no one could measure in 1902. Mapped evacuation zones funnel people away from every ravine the mountain has used before. Then, without further warning, the overgrown dome gives way. Gas-charged rock shatters instantly, and a glowing cloud spills downhill at hurricane speed, hugging every valley and street exactly the way it hugged the ravines above Saint-Pierre, faster than any car could outrun it. Within minutes, it reaches the coast, a wall of scorching gas and ash rolling over rooftops and streets the same way it once erased an entire city. The ground itself seems to glow orange beneath the cloud, and cameras capture the fury that fell on Saint-Pierre, now witnessed by the whole world at once. For a few minutes, the town lies coated in ash and silence, buildings scorched but standing, streets empty of the crowds that fled hours before. In the weeks that follow, just as in 1902, a tower of hardened lava could rise from the wounded dome, a slow spine of rock climbing inch by inch under its own pressure, then cracking and collapsing back into rubble. By week's end, the ash begins to settle, evacuation orders slowly lift, and the mountain falls silent again, waiting, exactly as it has waited for more than a century. Scientists still don't agree on exactly what triggered that fatal blast in 1902, whether the dome simply collapsed under its own weight, or a sideways explosion tore through the crater wall, or both happened together in the same instant. Even the numbers we love to repeat, the searing heat, the hurricane speed, come from clues left behind. Melted glass, scorched wood, distances measured after the fact, not instruments running at the time. The true figures may have been even more extreme. And we still don't know exactly how many people truly lived through that morning. One survivor's story, a prisoner in a thick-walled cell, became famous, but the full truth of who else may have escaped never made it into any official record. What's certain is that Mont Pelée proved a mountain doesn't need to erupt upward to change everything. Sometimes it simply leans sideways, and a city learns in minutes what that means, a lesson written into rock long before anyone was there to read it. None of this is a prediction, it's only a picture of what the physics allow, drawn from a mountain that has already done it once. Mont Pelée stands quiet today, green and cloud-wrapped over Martinique, its dome healed, its spine long since crumbled, but still, deep inside, holding the same restless pressure it has always held, while the villages below go on with their lives in its shadow, exactly as they have for more than 100 years. We examine one volcano at a time, this closely. Subscribe, and the next one will find you.